if you ask me a question, I'll just have to repeat it back. So people on YouTube, so this will be on YouTube. And I don't get the opportunity to have a mic very often, but I kind of feel like I gotta congratulate a certain person, a friend of mine, Mr. Jason Trinkline, the Associate Director of Infrastructure at College of Charleston, just got engaged a couple of days ago right here. Congratulations, Jason. Forever, this moment forever memorialized or whatever on YouTube. So you can always go back and rewatch this, man. Oh, we have a little thing in the way. Hold on one second. How do I get rid of this thing? Why don't I see this? Oops, nope. One second, let me figure, oh, it's on this machine. No, they can only see me, I think. Well, that's the wait. Oh, snap, is this gonna have the back of my head the whole time? Oh, crap. Okay, well, that's what's gonna happen. All right, come on, full screen. Okay, so tonight we're talking about, I called it event-driven config management. That is technically accurate with AWS Parameter Store. Thank you all, first of all, for coming out tonight. I really appreciate it. I'm doing my best to stay true to my promise, which is every 4 to 6 weeks. We're right about 6 weeks. As you might imagine, this is a fair bit of work to put one of these together. And eventually I am going to run out of stuff because I only know so much. So anybody else who would like to present, no matter how simple or how complex, doesn't have to be on AWS. Even though this is the AWS Meetup, it can totally be on DevOps. It could just be on really just tech, anything tech, software, etc. I would love to have you present. So if you have ideas that you'd like to hear about, or if you'd like to volunteer an idea, would be very much appreciated. But tonight we will be talking about config management with AWS Parameter Store. And for any of you who came for infrastructure config management, I apologize. I didn't put application config management in the title, but I'm not talking about Terraform, not talking about Chef and Puppet and Ansible and all that stuff. We're just talking about application config management. So I'm going to kind of, well, I know we have people here of all varying levels of experience. We're going to start kind of simple for anybody who's just kind of getting accustomed or kind of onboarding themselves to AWS and onboarding themselves to software development. So the purpose of application config management, or what it does, is it allows you to provide your application with custom configurations at runtime. So for all the ops folks who may not do a lot of software development, or those of you who do or who do not or do, that is what it's for. And if you want to know why, essentially I've broken it down to, it solves two major problems. One is, my application needs to run differently depending on where it runs. And I don't want to hard code configurations or secrets into my code. So essentially we need to dynamically change the nature of our application based on where it runs. And we need to provide it those configurations at runtime. So there's a ton of options out there for application config management. This is just a very small percentage of them, and I've seen many different companies that have lots of custom solutions. You can, of course, you can hard code your configurations, and technically that is a form of application config management, but is not really the best option. The most common that you'll probably see people using is environment variables, or they might use environment variables on top of some other solution. So you might set environment variables that at runtime, your application would see them, and then it would run differently or connect to a different database or something like that. A lot of people use properties files or JSON files. You point your application to a particular file when it starts, and it reads that file, and then from that, it bootstraps differently, connects to a different database, talks to a different API, so on and so forth. Amazon S3 is actually, I've seen a lot of people leveraging S3 for this purpose. As your application starts, it downloads a file from S3, and then it uses that file. So you can kind of, use these kind of together to solve the problem. And I've seen companies use that before. And then there's actually a lot of products designed specifically for this purpose. Console is one of them. It is a key value store. This has become kind of the standard The industry standard is very much like using a key value store to retrieve. You say, I want this particular, I have this key, give me this value. etcd and Zookeeper, you can use them for that. They're also kind of like key value stores that you can leverage for this kind of purpose. Ted, correct me if I'm wrong, I think like Kubernetes uses etcd behind the scenes for its kind of secret manager and config maps. Is that correct? Okay. Gotcha. Okay. That's what I thought. I'm not a Kubernetes expert. We do run Kubernetes, but I'm not an expert at all. We use it for very limited cases. So we have all these different options. Confused why it hasn't updated on that screen. Wonder if we have like network problems. Okay, there we go. We have all these different options, but AWS decided we needed another one. And so AWS came out with their own version, which is AWS Parameter Store. It is also a key value store. And it is a free, with quotes, service. As long as you stay on AWS, you can use it. There's now an asterisk next to free, which I'll talk about in a minute. But originally, it was just free. It natively integrates very nicely with AWS IAM, Identity and Access Management, which makes it really easy to control who and what has access to what configurations. Of course, it's all based on how you implement in like namespace and things like that, all of your configurations, which I will go over. It has a built-in audit log. So if you change a configuration, we know who changes it, from what, and to what. And so you have versioning kind of built in. It's kind of part of that audit log. It's got a nice integration with AWS Key Management Service for encryption. So you can select a key and just say, I want to encrypt it with this key. And the AWS SDK, or however you interact with it, will handle that for you. One of the biggest wins is that it's serverless. All those other ones I just put up there, Console, Zookeeper, etcd, those all run, you have to run servers. Now you have to manage servers, you have to patch servers, you have to manage your access to those servers. With Parameter Store, you don't have to deal with any of that. All you have is an API that you interact with, and you say, I want this value, and you pass in some credentials, and if you have the credentials to retrieve that value, you will get that value back. Otherwise, Amazon will tell you you don't have access to that value. The kind of limits are, up until recently actually, because I need to double check them now, there was a limit of 4,096 characters for any one value. But I think they just released, this might be literally in the last couple of weeks, you can pay for more. So if you want to store a larger key than 4096, I think you can pay, and I don't know if it's like per retrieval or for how long. I don't know how exactly that pricing scheme is. I actually meant to go figure that out before this presentation, but I totally forgot. And also you're subject to AWS API limits. So if anybody here has worked with AWS API, you can get throttled. But I think they also changed that where now you can just pay to not get throttled. So, but if you don't want to pay, weird, I lost my presentation. If you don't want to pay, you can just stay within those limits. One of the downsides, I don't know why it's not presenting. One second, guys. Technical difficulties here. Come on. Oh, you know what? It's the Wi-Fi in here, man. It just kind of like disappears for a moment and then comes back. Hey, we're back. Okay. We're going to go through this a few more times tonight, guys. So I'll just kind of talk through it next time now that I know what it is. So the audit log only exists as long as the parameter. So one of the issues is that if somebody accidentally deletes something, not only do you lose the parameter, you lose all the versions of the parameter. So you've lost all your history and you don't know who changed it or did what, et cetera. So that's kind of a trouble. And you can have a max of 100 versions per parameter. So if somebody changes it 101 times, you're going to lose the first value. Does anybody have any questions about parameter store or config management, et cetera? Everybody good? Cool. Okay, there it goes. So at Snagajob, we decided to change from console, which is what we're using for config management, and move to a new solution. And we kind of came up with some config goals. So if we're going to make this change, we want to get something out of it. So kind of came up with a few things that we would like to get with our next solution. So this would change depending on, well, the solution we chose would depend on whether or not we could get some of these things out of it. One thing we wanted to do is we wanted to have this clear binding of an application version to configs. So if I see version, some git hash, because that's how we handle our application versions. If some git hash, some version of an application is running, I want to know exactly what its configs are for any particular environment. I don't want that to not be clear. A lot of times if you don't have versioning, or if you don't have this clear kind of mapping, you can have a situation where the application, you don't know what it ran as in the past, things like that. So I want to look at just a git hash and know exactly what configs it used at any point in time. What that means is we need a clear dependency between applications and versions, and we need config versioning support, which parameter store does have. And also, I don't know what the deal is with the internet here. Also, we wanted a situation where unused configs are cleaned up. One of the things that is it's very, very, oh my gosh, major technical difficulty. Sorry, guys. One of the things that is very, all right, you know what? We're just gonna like not use that screen. I'm just gonna look at this one going forward. What, did Chrome crash? Okay, we're back. One of the things that was very frustrating for me is that what's really common when you have a key value store for your configurations is that people put stuff in there and then it's no longer used, or maybe it was never used, and nobody has any idea what it's used for, and they're terrified to delete it because they have no idea what it's for. And so I would see stuff, and even if it's named delete me, you can assume it should be deleted, but at times perhaps not even should not be deleted. You don't know what's going on. So it's very frustrating. So I wanted to have a situation where, you know, if you have a clear dependency map, you know what applications rely on what versions, therefore you can infer exactly which ones are used and which ones are not, so you can know what you can delete. Another thing is we wanted to remove global configurations. So if you have global configurations that many different applications can consume, then if one of them stops consuming it, or if you look at that configuration, you don't necessarily know which ones are consuming it because everybody has access to it. So everybody could be consuming it. So one of the goals was that we would remove the concept of global configurations. Instead, it would be very clear this application consumes this thing. We also wanted to have a backup, audit, and restoration process. Our previous config management solution of console, you could kind of take a snapshot and you had to do it manually, and you had to kind of do it. We did it every 4 hours. So if we wanted to restore, we'd have to restore all the configs. But what if somebody just deleted one of the configs? How do we restore just that one? That's kind of a troubling solution. So if we roll back, we have to roll them all back, but then we don't know if somebody changed something else that we want to keep. So that's a challenge that we wanted to address with this new solution. And also, finally, for the developers, I really wanted to have a solution where if somebody's missing a config and they try to do a deployment, the build breaks. That's something we did not have. I have an open source project called the flapping container detector. You are welcome to use it. It's designed for Elastic Container Service, ECS. But one really common thing that we see, we have, I don't know, 180-ish or so microservices. Somebody deploys a service and they forgot a config. They're referencing it in their code, but they didn't actually put it in console or in parameter store. What happens is when the code goes to Bootstrap, the container starts. It can't get all of the configs it needs, and so it just crashes over and over and over and over and over and over and over again, and that's what I call a flapping container. So the solution was to break the build before it could possibly deploy something that had no chance of ever bootstrapping correctly. And so we have, it's still possible for a container to flap, but it's a lot harder to have it do that for the sake of config. So this was one of the goals that we had. So what can proper config management solve, considering some of our goals? The first two bullet points were from a previous slide, which is my application needs to run differently depending on where it runs. I don't want to hard code secrets into my code. I want to track configuration changes over time. I would like to know what dependencies any individual application has, because its configuration tells you a lot about it. I want to version my application's configurations, back up and restore old versions. And I want to limit access to application secrets. I want to follow the principle of least privilege. And finally, I want to prevent deployments that are destined to fail due to invalid or missing configurations. Now, these are all possible with enough work. Parameter store for all of these items have a little legend in the top right. Parameter store supports 2 of these fully, which are the first 2. Just by using parameter store, you can have your application run differently in each environment, and you don't have to hard code secrets in your code. If you want to track configuration changes over time, you can do that with parameter store because it does support versioning, except if somebody deletes it, then it's gone and you can't really track it over time. You can't restore it, things like that. So you have to have your own custom restoration and backup process for parameter store. I want to know what dependencies this application has. That's not really relevant, but to parameter store in particular, it's more an implementation specific thing. But how you leverage parameter store, you could potentially get that. If you want to version your application's configurations and backup and restore old versions. I'm sorry, guys. Put it back up again. All right, we're back. If I want to limit access to application secrets and follow the principle of least privilege, parameter store totally more or less supports that with IAM, but it's the reason why I have it kind of supported is because it's specific to your implementation. You can still, not handle privilege like appropriately, and people can have access to a lot more than they need. So it's yellow because using parameter store doesn't give you that natively. You still have to do it properly. And I want to break deployments when configs are missing. Also, parameter store doesn't support that. Does anybody have any questions on parameter store or anything I've gone over so far? Everybody following? It's cool? All good? Okay. In other words, parameter store is no silver bullet. So we decided to kind of take a new approach to application configurations. I really want to fix this because I think the recording is going to be messed up if I can't manage to fix this. So give me just 1 second, guys. Let me just try stopping the share for a second. How do I stop the share? I don't know how to use. Okay. Now I'm just sharing that tab. Now let me just go back to my desktop. That looks good. Okay. Apologize, everybody. Okay. So we decided to kind of come up with a brand new solution that was specific, that would solve all of our kind of goals or hello? Okay, sorry. So we decided to come up with our own kind of solution that would hopefully check all the boxes of all of our particular goals. So the first thing, we had to do is consider the stakeholders. So depending on the size of your organization, these stakeholders might change. We decided that there were 3 main kind of groups in engineering. There are stakeholders to application config management. We have developers, we have the database administrators, and then we have DevOps. Those groups have their own unique story. I call it the developer story or the DBA story. Basically, how they work is their story, how they interact on a day-to-day basis and develop and build what they need to build. That is their story. And they have particular concerns that are unique to each one of these particular groups. The developers are concerned with security. I actually lied. They're not concerned at all with security at all. Maybe 5% are concerned with security, but they should be concerned with security, especially their application security. But they are concerned with empowerment and efficient local development. Basically, developers just want you to get the heck out of their way and let them do what they got to do, and they don't want to be concerned with security. They want features that support velocity, reduce risk, and catch bugs. That's what developers want. Database administrators actually do care a lot about security, frustratingly so a lot of times. They are concerned with how they handle database secrets. How do they share those database secrets with other engineers, things like that, or applications? And also secret rotation, which is an important part of maintaining your database. And they also want a simple solution. Developers, DBAs, they don't want a solution that's going to create their day-to-day more difficult. I'm on the DevOps team. One thing I've learned is that if you want to build something and get other people to use it, you have to give them a compelling reason to use it, i.e. it's easier than what they were doing before, or they're getting something out of it that's going to save them time If you just say, hey, you all have to do this because this is the new way, people will just resent you, or they just won't do it, and they'll just do whatever they want to do. So the best approach is to develop a solution that solves what your needs are, and also makes their day-to-day a lot easier, makes them happy. So on the DevOps side, we have a major concern for security, also disaster recovery, resiliency, secret sharing as well, because we own lots and lots of secrets, and also local development, because we are developers as well. We write a lot of code, and so we leverage the pipelines that we build, and so we don't want to create a bunch of hoops that we have to jump through when we're trying to do more work. So we have a little bit different story than the developers. Now, the people who are most likely to be the most frustrated by a bad solution are the developers, because they have a dependency on the database administrators and DevOps. So if I make a story that is bad for DevOps and a story that is bad for the DBAs, then the developer is going to be doubly frustrated, and I'm going to hear about it. So I really need to consider them and have a good use case or solution for everybody, so that they don't get frustrated and just refuse to use the new system. So because we had three kind of main groups, kind of decided that it makes sense to break them up into three different tiers of access. So the developers are responsible for the application. The application has its own individual secrets and its own individual configurations. So they are kind of under the app tier, and they manage all of that information and all those configurations. The database administrators, they have their own unique tier that is /data in our case. That is for DB configurations and database secrets, things like that, secrets and configs that they own and manage. And then /DevOps, that is for everything else, because we manage API keys and third-party access and all this kind of stuff, even AWS keys. So what we have done is we added one more namespace called shared, which everybody has access to. And so that gives us four kind of root namespaces that which we can kind of break privilege apart fairly easily without having super complex policies. So developers, database administrators, and DevOps all have access to the app namespace. So if you store a parameter in parameter store and it's prefixed with /app, then all these people, all three of these groups can read that value essentially. In /data, only database administrators have access to that namespace. So I personally don't need access to the database passwords, and I shouldn't have access to the database passwords, even though I'm DevOps. Likewise with /DevOps, DevOps people have secrets that really DBAs don't need access to, and neither do developers. And then shared is a kind of global non-secret namespace where you can store kind of global configs, but they're not actually global configs, and I'll go over that later. And each of these has their own encryption key. App/app namespace has an application encryption key. So if you're going to encrypt a secret and store it in the app namespace, you're going to use the application key. So the developers would have access to the application key. /data, same thing, data key. /DevOps, DevOps key. And then there's this other key called the replication key, which I'll go over later, which is different and special, and not everybody has access to that. But what about the application? So of course, there's a fourth group, which is the actual services that run on our servers, and they need access too. So you might think, well, an application needs access to all of these namespaces. So if I'm deploying an application, it's going to need access to pull parameters from shared, from app, from data, and from DevOps, because an application does talk to databases. An application does talk or does need access to access keys, things like that. So an application might need access to all of these different namespaces. So problem solved? Well, potentially, but not really. There are some problems with the pull model where an application would reach out to all these different namespaces and pull the value. One of the problems is the application would then need access to all the different encryption keys. So if you have database administrators store a value in the data namespace and encrypt it with the data key, an application would need to pull it. There's also still no clear dependency mapping. How do we know, which app uses which configuration? And we have no solution for auditing, backup, and restoration. So we kind of decided to invert it all, which is push, don't pull. So if you have a configuration that your application
Awesome, thank you. All right, you want to?
Testing, testing. Okay. Share.
Hey, Jordan, Zach, can you hear me okay?
Yeah, man, can you hear me?
Yeah, and just if there's like a kind of continual issue, like I can always get that link and present my screen, and you could just tell me to change the slides going forward, backward. That's just last option, but just giving you a heads up.
Okay. I will let you know, man, if we need to go.
All right, dude.
Yeah. We might yeah, invert it, push, don't pull to you, Zach.
Right on.
Okay, so our solution. Everybody cool? Anybody have any questions real quick? Jason?
Are you saying that all of your applications share the same namespace?
They all have their own, well, that's the next, next slide. So the question was, are you saying that all of the applications share the namespace? How do I get this to go? Gosh darn it. Sorry guys, there's like a really bad delay. Okay. So if you have multiple applications, they all start with app, but every n number of applications underneath the root app namespace has their own unique namespace and their own area of access. So if you have an application named foo and an application named bar, they would all, foo would have access to /app/foo and bar would have access to /app/bar, and only that. So it's very clear if you look under /app/foo, I now know exactly what foo's configurations are. I know all of its dependencies. I know everything I really need to know about that, which is important when you have, say, 190 different services and someone says, Jordan, something's broken and you need to fix it. This thing is slow. And I usually, if you have 190 services, if one thing is broken, it's usually not that thing. It's usually one of the 189 other things. And so one really nice thing is I can just hop into bar and look at its configs real quick, print them out, and I can see everything it talks to, every database it connects to, every other service that it connects to. I can know that. So now I have already limited all the different other options of what could be the problem. And I can have a better idea of where to start looking if bar is acting up in some way. Does anybody else have any other questions? That makes sense? Yes. An application only has access to its specific namespace that gets provisioned for it. So when the application is created, this namespace is essentially created for it, and only it has access to that and nothing else. So it does not have access to anything in data or DevOps or shared or anything. So if it needs a configuration, it has to declare, I need this configuration, and we will push that configuration to it magically, which is the whole event-driven thing, the whole event-driven nature of what we're talking about. So this happens how? AWS CloudWatch events, of course. So with parameter store, there's a really nice thing where if you put a value or change a value, do anything in parameter store, that generates an event. That event goes on what's called the CloudWatch event bus. The CloudWatch event bus, there's now an event on that bus. You can consume that event, and you can do something based on that event. So every parameter store API call, at least I didn't 100% fact check that, but as far as I know, everyone generates an event. So if you create a parameter, if you delete a parameter, all that kind of stuff, that's an event, and you can consume that event. These events are very easily usable or consumable via Lambda. So in this example, our database administrator put a password to Mongo under this particular path, and that password generates an event. The payload looks something like this. So the payload says, this parameter was changed, its name was foo, and the description is, there's a description, you can have a description for every parameter, just so anybody coming behind you can know what that thing is. And actually, this doesn't show it here, because in the example AWS docs, but actually you can see the value, but if it's encrypted, it will be encrypted. If it's not encrypted, you will not see the encrypt, or it will be just a type string. This is an unencrypted type. In parameter store, there are two main kind of types. There's string and secure string. A secure string is an encrypted string, so you would see the whole encrypted payload. So if you consume this event, of course this is private, so not anybody can consume it. This is within your AWS account. Somebody puts a parameter in your AWS account, this event is generated. You can actually consume it and do something as a result of this event. So it looks something like this. I'm managing so many different screens. Okay. Sorry, gosh darn it. Okay. Move this thing down so you guys don't have this thing in your way. So some database administrator puts this password that triggers an event. That event ends up on the CloudWatch event bus. It is consumed by a Lambda. And the Lambda says, oh, well, application foo needs this password under app foo mongo password. So at that point in time, as soon as the password is placed, it is automatically replicated, is what we call it, replicated to the destination, which is in the namespace of the application. So the application does not need access to the data namespace or where the parameter was originally put. It only needs access to its namespace. This is how I can go in and look at app.foo and know all of its dependencies, well, all the databases it connects to, because I can just see the names of everything that's in here. So I would know foo must connect to Mongo. Does anybody have any questions about how that works? Good question. Why doesn't the DBA write directly to the app key? The DBA could write directly to the app key, and in this particular case, that would be fine, potentially. The main thing is that in a lot of these cases of replication, you'll have one thing that's replicated to many places. So the DBA would have to remember to put it in all of those places. This is a Mongo password, so this would only be used in one place typically because every service would have its own unique credentials. But in many cases, you have parameters, like shared kind of global parameters that are used by many different services. If the DBA put it in there, another thing is it's a separation of concerns. So this is encrypted with the data key. The source of truth is encrypted with the data key. When the value is replicated, it's encrypted with a different, what's called the replication key that is unique that only applications have. So no human user can go in and see this value. If the DBA put it in here, obviously he would have to have the key to put it in there, but even the DBA doesn't have access to the replication key. That way only applications can view their own secrets. So in order to make this happen, we have something called a replication configuration. I hope this is large enough. Maybe the screen is. A replication configuration is basically just specifying declaratively, this source path needs to be replicated. This is the source of truth for this value. It needs to be replicated to the destination. So the destination in this case, so if this is a DynamoDB table, this is a key value store. Destination is the primary key here. So every single destination can only be replicated to from one source. So if you put a value in source, this is saying, hey, I want this to go here. This is how the Lambda knows where it should go, because he's going to look at that table and say, hey, do you have a destination, or where does this source go? And it's going to then put it where it's supposed to go. So most of you probably think that's not worth it, and that's a reasonable thing to think. But if we consider the goals, some of our goals were to reduce the application footprint, to clarify dependencies, and to limit access to encryption keys. By doing this and leveraging this process and using events, the footprint without replication is that a single service being deployed would have to have access across all these different tiers, the shared tier, the application tier, the data tier. But if we replicate, we're basically pushing everything to just its namespace where it has access. And so now it's very clear, and all of its access is in one place under one particular namespace, which makes IAM policies very easy to write, rather than having to write a custom policy for every service or designing something that's a bit more complex. So this is kind of one of the advantages of this approach. Does anybody else have any questions? Jason. The question is, do the Lambdas need access to the encryption keys? And the answer is yes. If the Lambda is doing the replication, it will have to have access to it's really the only thing that has access to all 4 keys. Yes. Any other questions? To the replication config? Oh, okay. So we have a custom tool that we wrote in-house. One thing about Parameter Store I didn't mention is that it's User interface is terrible at best. It's really it's miserable to use. And after about 10 minutes, I was like, I'm just going to write something else because I just can't handle this thing. So we have our own CLI that we use, which is kind of leveraged internally. We call it the Snag CLI. It's leveraged by all of our engineers. They use it for many different kind of automated purposes. And it is used to interact with Parameter Store. And it's kind of integrated with our single sign-on solution. And you sign on through your normal username and password with our single sign-on solution, and then it gets access to AWS that way and does all this other stuff. So and I'll show, it's in the demo. So you'll be very clear when I do it. Correct. They create the parameter, yes. That anybody can create a parameter? Well, no, because, well, I'll talk about it later, but we have a clear mapping of, well, one, we have an audit trail of every parameter is created by who, et cetera. But also, every application's dependencies are clearly defined. We know exactly what it uses, which I haven't gotten to how that happens, but because we have that, we can pretty easily go through and find out anything that's not used. So it hasn't been a problem so far. My favorite part of the advantage of using the kind of event-driven approach and leveraging CloudWatch events is this. So if somebody puts this Mongo password, so sticking with the previous example, they put the password into Parameter Store, that triggers an event. That event goes to the CloudWatch event bus. Now the replication happens, but you can consume that event twice. Another interested party could consume that event. Perhaps a party interested in backing up this entry. This entry would then be inserted, this event that happened will be inserted into a database which stores the time at which it happened and everything you need to know about this event. So it would store, say, the value, the encrypted value, if there was an encrypted value, et cetera. So the really nice thing about this is that as people interact with Parameter Store and change our configurations, we are automatically backing up as they do them, and we know the exact timestamp when they do that. So if somebody deletes a parameter, we just get a delete message and we just put it in here, but we don't delete the backup, so we know what the previous value was. So we have a full history of that parameter. If it was created, deleted 10 times, we would have that. We'd be able to replay all of those events until we got the actual value we wanted. In fact, we have a restoration process that replays all the versions. So if you delete a parameter that had 99 versions, it would add them 99 times in a row to recreate the full versioned history of that parameter. The way it works is something like this. This is the audit table. It's Dynamo. This is an example of an action. The action was a put parameter. This is the value, which is the encrypted string. The encrypted string was encrypted with some particular KMS key, so there would be an ID of the key that encrypted it. So if you needed to actually get that value to restore the parameter, you would have the ability to do that. And it was done at this particular time. This long integer is just seconds since epoch, or yeah, it looks like seconds. And it says the user that did this as well, so we know exactly who deleted or changed the parameter. What this gives me, particularly, is that I can say, Joseph, you shall restore my configurations to a specific point in time yesterday at 5:43 p.m. in 37 seconds. That's the time. And I can restore not just the entirety of parameter store. I can say just restore this one parameter or this hierarchy of parameters, any individual breakout. So I can restore anything to any point in time in its entire history using this streamlined event process that constantly backs them up. So if we look at our config goals, we've got some wins here. So this new process gives us no global configurations. I mean, kind of. The global ones are not referenced by any other applications because applications have their own specific configurations. We have a clear application to config dependency. So if I look under /app and then the application's name, I know exactly what it uses, which is great, especially for me, for troubleshooting and things like that. We now have a backup process and an audit and restoration process, leveraging Parameter Store with the CloudWatch event bus and a DynamoDB table. But we don't have a binding of configurations to application versions. So I can't break the build if someone forgets to add a config. And it's not just that people forget to add configs. What happens more frequently than not or maybe not more frequently than not, but very frequently, is that someone develops in one environment. They develop in dev. They add the config in dev. They submit a pull request. That pull request gets merged to QA or stage or what have you call it. They forgot to add the config in QA or stage. So now their service is destined to fail when it starts. There's no chance of it successfully bootstrapping because it requires that configuration. That's why we have the flapping container detector, because containers just repeatedly restart over and over again because they don't have the configs they need to properly start. So back in the developer's shoes, if we have the config goal of breaking the build, if they are missing a particular parameter or dependency, what we need, there's no way around it, is that the application has to define in some way what are the parameters that it needs. So there needs to be some sort of declarative definition of, in order for me to work, I need these things to exist. So that's what the developer has to do. What he or she gets out of it is that they get the advantage of not having to be afraid of deploying something that's to production that's guaranteed to fail. And configurations are one of the most common things where you're going to have production issues because it's hard to test for them. So when you deploy your code to production, the config could be missing, but the config was in UAT or in QA or stage or in those other environments. You just forgot to add it. So this will protect you from deploying something that has no chance of succeeding, even in production. And you can't test very easily that it's going to work in production. So our continuous integration and deployment process can parse this declarative config and check all the parameters to make sure they're all there. This is accomplished by a file we call the config.json file, ci-config.json file. I can have a whole nother talk on our CI/CD process and how that works. But what you need to know is that we have a file that every developer puts in their repo, and it says, this is how my service should be deployed. It's similar to a config.yaml in Kubernetes, where you define how that should be deployed or run in Kubernetes. Our automation code parses that file and then constructs and deploys that service as they asked for it to be deployed. So if they said, I want this to run, I want it to be scaled based on CPU, I want it to have a load balancer, I want it to have this particular DNS entry, things like that, they would just define how it should be deployed, and then we will make that happen. We will make it so. So we already have this file, so we just added some blocks in this file that says, well, and I also need these parameters to exist in parameter store in order for me to run. And since this file is versioned in GitHub, every single check-in, you can just add the parameter that you require, and then we can break the build if it doesn't exist. Does anybody have any questions about that? Yes. Okay, so the question is, for the recording, for Zach, do the developers interact with parameter store when they develop locally? How does that all kind of work? So the answer is, yes, they do, but it depends. So depending on a implementation of how a particular code base works, some people have defaults that automatically get set, and then if the parameter store value exists, it overrides it. Other people have defaults, but then environment variables override it and they supersede all others. So even if the value exists in parameter store and it checks it, it would then take the environment variable over that. But most developers just put the value in parameter store and then just run their app locally, and they have temporary credentials that they generate that give them access to that value, only in the development environment. So developers need access to the configs for all services in our lowest environment. In the higher environments, they don't have access to all the configs, so they can't run their app locally and point it against production configurations. They simply couldn't decrypt the configurations. But for dev, they could. Does that answer the question? Anybody else have any other questions? No? Okay. Roger that. Okay. All right. That sounds, I mean, I don't mind them throughout it kind of breaks things up a little bit, but okay. I'll wait, or we'll wait. So that CI config.json, it has a little block in here called the app parameters block. This is saying my application, in this case, it's CI test. It's bigger over here. /app/CI test, it needs these parameters, config 9, config 11, and config 12. That would be checked in. So when you added those configs to your code, you would retrieve those values. You would also need to add them here. The brilliance of one of our engineers is that you can actually infer what parameters you need from the code. So actually during the build, most of our code bases dynamically generate this list. So if you pull a parameter and you're saying, I need this parameter, during the build, we'll dynamically generate this list of all the parameters that you're actually using and just populate it here, so you don't have to worry about synchronizing what's your code's using and what this file has. So all you have to do is just use the parameters you need, and if you're missing one, the build will automatically detect it and break the build. If your code stops referencing that parameter, the build will no longer have that added, and it won't break the build. Gotti, I know you have a question. Go ahead.
Is there any protection against somebody checking in? Let's say you have this build checking process.
Yes.
So it's statically analyzed what code. So that it doesn't do it. It collects all the.
So I didn't write the code, but I believe there's for our .NET Core projects, they run a particular like .NET command that runs the app, and then it detects all the ones that are used, and then it writes that out to the file. No, they can't abuse that detection system. So the question was, could somebody so what they would have to do would have to like break into our build server and get access to that, and then leverage the keys, because that build server has to, the thing is the build server only has access to whether or not the thing exists. It doesn't have access to the value, because it doesn't matter what the value is. We're not concerned about the value. We're concerned, does this config exist? So we could only protect against missing configs. We can't protect against wrong configs, because we couldn't possibly know what is wrong. So the build server just looks at this does a describe all and just pulls all the parameters under a particular hierarchy. So in this case, it would just pull all the parameters under app CI test, get that list, and then, turn it as a set and do a union, or sorry, not a union, but a, what's it called? Difference, essentially, of the two sets of what was defined there and what it has. If there's anything that doesn't link up, then there's a problem. Either you have a config that exists in parameter store that doesn't exist in what's defined here, or you have the inverse. If it exists in parameter store, we call that like an orphaned config. That won't break the build. We'll just notify you about it. The alternative is if you've defined a config and it doesn't exist, we break the build. Yes. No, so okay, so we do not, so the question is related to the versioning of the configs and whether or not we bump the version every build and things like that. So as DevOps, I do not tell developers how they have to manage their configs. If they want to version them, they can. If they don't want to version them, they don't have to. Parameter stores versioning is just if you change a value, it keeps track of the last value, and it has its own kind of internal version. You wouldn't typically want to reference a previous version of a parameter store one, because people sometimes make a typo, then they override it, and then now you've generated two versions and you have to skip. So really the best way, in my opinion, this is just my opinion, but the best way to handle versioning of your configs is to version it in the name of the config. So in this case, this is app CI test v1 config 9. Now, a user would not change this unless they needed to, they would only use v2 if they needed to change the value. So if they change the value, they should just put it under v2. So they should create a new config 9, so /v2 config 9, and then reference that in their code, and then reference that here. That's what I would personally recommend. But not all of our engineers do that. Some of them version them with the name, some of them do not. It's not related to the application version. It's more related to the version of this particular parameter value. So if you had v1 config 9, v2 config 9, and then I think the best approach for handling actual, that's handling actual versions of what is the intended value. The parameter store version is more for like, if you type in the wrong version and then you override it, whatever the latest version should be the actual version, if that makes sense. So for shared configuration, so there is one thing that's missing here, which is developers need access to configs that they all share. We don't want them to have to manually put in every single one of their configs. So there should be a source of truth. So for instance, a particular service lives at this address. The source of truth of a non-secret configuration is under the shared namespace. And so they would just define what we call this replication config inside of their CI config.json, which just declaratively says, hey, this configuration under shared common S3 buckets assets, which would be, say, maybe an assets bucket, I need that value, whatever it is, under app Jordan Mance replicated assets bucket. So I can just declare what I want, and then magically we will make it so. That's DevOps' responsibility to make sure it's at the right location. The developers just declaratively state, this is what I want. So this is for non-sensitive configs only, but this uses the same process that we saw earlier with the event-driven replication that database users use to share secrets to engineers, things like that, or to applications. We also have a concept of a merge parameter. A merge parameter, this is just because engineers used to use this and they liked it, so it's more of just like a nice to have. This thing's in the way at the bottom. I'm going to move this real quick so you guys can see. Essentially, a merge parameter is particularly useful for connection strings where you have a username, you have a password, you have a host name, you have a port, you have a database name, things like that. A lot of times engineers don't want to have to pull all 5 of those, URI encode the password and the username, and then connect to the database. Instead, they just define, well, I want these 5 in this order and this one little merge template in their file. And then magically, we will do all of that. We will URI encode the username and the password if they say they want that. And we will create this Uber parameter and put it at the location they want. So they just pull down the Uber parameter and then they connect to the database. So in the config file, they would put something like this. At the top, you have a destination of where you want it. So if your application is named foo, you might say, I want this to exist at app foo replicated MySQL connection string. And inside of that, you have a list of other strings that represent what you want to be merged together. So you can provide a string like JDBC : MySQL : // which is the prefix, is just a string. But if you wrap any string in these $sign brackets, we will then dynamically infer that that's a parameter you want. We'll go look up that parameter, decrypt it, put it encrypted at the destination as part of that Uber string, and build an ideal string or the string that you want. So all of that will then be available to you under MySQL connection string for your applications. All you do is just look up, all you do is look up the connection string, and now you have what you need, which is the merging of all of those different configurations. Finally, database passwords. Oh, sorry, somebody has a question? Okay. So, let me move this thing again. So this is Steve. Steve is a well-known DBA at our company. He's a great guy, but he's a little ADD sometimes, and he asks a lot of questions. He talks a lot. So this is how you got a database password. You had a new service you wanted to create. You had to talk to Steve. You had to get through the gate of Steve to get it. In the past, you would say, hey, Steve, I need a new username and password. And he would ask you a lot of questions because Steve is very concerned with security. And also, he thinks you probably don't need the thing that you want. And so he's going to ask you a ton of questions, and there's no way around it. You're going to have to get through the gate of Steve's questions. Once you have done that in the past, Steve would then create you a username and password. But he's got to do it for all of our environments. So he's got to create 4 new users and 4 new passwords. He's then going to create 4 LastPass documents, some sort of document, and then he's going to put them in there, and then he's going to share them with you. That's going to generate 4 emails. You're going to have to log into your email, click on the email, accept the share 4 times. Then you've got your 4 username and passwords. Now you have to go in console, encrypt them, put them in console, then update your application code to decrypt it. That was the former process. This is a very frustrating process that people had to deal with on a regular basis. Steve is a real person. The new Steve, he's much cooler now, much more, he's got very hipster glasses, got a nice little hat. The new Steve, you still have to answer a lot of questions. Steve's still Steve. But once you get past the questions, all you say is, Steve, I need this username and this password here. I want you to put it under app demo time replicated DB password. I don't care. I don't want to see it. I don't want to know about it. I'm not responsible for it. It's my application's secret. It's not my secret. So I don't really care about having it. So what Steve does is he creates it. He puts them in parameter store under Steve's data namespace, and then Steve shares it to the destination that you defined. Now, you've never seen it. If it gets compromised or something like that, it couldn't have been you because you never saw it, and it was encrypted with a key that you don't have, so it couldn't have been you. This is a much more secure way to handle passwords. So that is how we do it. And this is also using, of course, events, things like that. So he just adds it to the data namespace, and then he configures replication. Steve also now owns rotation of the password. He just updates the username and password in his namespace. They will be replicated to the destination, and the next time your app bootstraps, it will just pull the new credentials. And so Steve can develop his own strategy for rotating credentials, and you don't even have to worry about it. Okay, so the Snag CLI. This is, I have a little mission statement. This is our CLI tool that I mentioned earlier. Support CLI tooling in support of the developer story. So DevOps CI, it's like two peas in a pod with DevOps CI, which is our automation repo, which does a lot of magic. The Snag CLI is how Eric had asked earlier about how we actually put stuff in parameter store and get stuff out of parameter store, things like that. Well, Snag CLI has two parameters. So you say Snag CLI, you specify a resource, of which you could specify config, which would have functionality around talking to parameter store or talking to console. And then you would have a command. So the config commands are browse, list, get, put, delete, dump, share, audit, restore, migrate, sync, and clean up. And depending on your level of access, you would be able to use those commands. This is what our developers and our engineers, our database engineers and our DevOps folks use every single day to work. This is also how they generate temporary credentials so that they can work locally through our SSO provider. The two main commands that are important for this whole event-driven process is config sync. So developers running locally, they're running their app locally, they will sync their desired state, which is what's defined in this JSON file, with what is actually in the world, in the environment. So in Dynamo and in parameter store. The sync will create replication configs that don't exist. It'll verify that all the parameters exist that they want or that they need. So when they commit their code, if sync says everything's okay, then your build's gonna pass in terms of all the validation steps that we have. So sync will just do the validation locally so that you don't commit and then break something and then have to create a new commit to fix the missing parameter or something like that. Sync triggers replication. So we also have a different kind of event that we need to trigger replication from. So DynamoDB has a concept of DynamoDB streams. With DynamoDB streams, anytime you do an insert or delete or do anything in Dynamo, that generates another event, just like that CloudWatch event stream. That event can be consumed, of course, by a Lambda, and that Lambda can do something with that event. So in this case, if you synced and you added that replication config that says, hey, I need this Mongo host name and I need it in my application or available for my application to consume, that event would be triggered immediately. Replication would happen, and then the host name would be shared with your application. Does anybody have any questions about DynamoDB event streams, or this is the only kind of place where we use it in this case for the event-driven config stuff? So basically, before someone commits, you just run sync. If sync passes, then you're good to go. You can commit. If sync fails, you should address the things it tells you to address, and then you try it again. And then finally, there's cleanup, which is like sync. Sync will tell you, hey, you've got unused parameters. You've got stuff that you clearly don't need, but I see it in parameter store. I see it in Dynamo, and you don't have it defined anymore. You deleted it. Where did it go? Do you want that? And you will run cleanup to clean up those things. So it will prompt you on a case-by-case basis. Do you still need this parameter? You're not referencing it anymore, or something like that. So just get rid of configs. This is how we keep our parameter store environment clean. If somebody no longer needs a config and they're not referencing it anywhere, then when they run cleanup, they'll be prompted and it will get cleaned up. Does anybody have any questions about that? All right, so demo number 1. We got 3 demos here, folks, so bear with me here. I'm just gonna demo sync and replication, this kind of DynamoDB stream thing, how it works. So, and I'll kind of show you what the Snag CLI is and what it does. The question is, if I didn't have the Snag CLI, would I use Terraform to manage parameter store? The answer is probably not. We have used Terraform to define parameters. It gets a little hairy because you either have to hardcode the parameter in the Terraform, or you then have to use Terraform variables and you have to store them somewhere. So I think it's probably better to just interact directly with the API or use an AWS CLI or something like that. Terraform does make sure that if you did define every variable and parameter store in Terraform, then you have that clear idea of what's in there, which would be nice. But so many developers need to interact with parameter store. Not everybody's going to learn Terraform. So maybe just for some DevOps specific configurations, we might use it. But for the most part, we've just kind of skipped that and moved on. Yes, Ted.
How does each of your 190 apps consume parameters? Do they have to be updated to default? And then also, so that's like a startup, and then also if DBA role is the database password, then how does that update get pushed to the app? Have to start and pick it up? You know, what's that mechanism?
Mm-hmm. Right. Well, I'm going to demo something called parameter store template, which does what console template does. Pretty legit. The question is, how does each of our individual 180 to 90 apps, whatever, actually get all of these parameters from parameter store? The answer is it depends on the language, because we have a bunch of different languages. Most of our applications are written in C# and they use a shared library. And people just follow certain conventions and they import that shared library. And in their code, they just define in Java, they're called annotations. I don't know what they're called in C#, but basically you're just saying, hey, I want this parameter, and it injects it into your code. So you don't have to do anything. You just put a little annotation above a property in a file or in one of your classes, and then it just shows up where it needs to be. And that happens at Bootstrap. Some of them, and I disagree with this approach, but I'm not in charge of everything. Some of them auto reload parameters on an interval. So if you change a parameter, it would reload it. In fact, I'm going to demo doing that, but I don't think, generally speaking, I think it's a bad idea, except in some specific use cases. Others like Python and other languages, they typically just load them at Bootstrap. They just have a class that uses the AWS SDK. So when they're running their code executes, it just gets all the parameters they need and loads them all at time. The .NET one is lazy loaded, so it will actually, I believe it will just fetch them as they're needed, and if it's never needed, it will never fetch them. One thing is that constant reload, where like every, I think it's 5 minutes, some of them will get it's like a configurable option. They will get the current value every 5 minutes or check it. We have to be very careful with that, because if you have a whole bunch of them, or if that interval is too low, you will be hitting parameter store all the time. And you can start getting billed for every single one of those lookups, and you might not even need them. So the next demo is actually demoing how you can do that without having to look it up on a regular basis, how you can receive an event with an updated value because it changed, rather than you having to go fetch it and be like, did this change? So that's demo number 2. Anybody else have any other questions? Jason.
How do you prevent merge templates from dumping sensitive parameters?
Question is, how do you prevent merge templates from dumping sensitive parameters? So merge templates, they merge a bunch of different parameters into one, and they're all stored in parameter store. If you have access to you have to have access to all 5 of the merge parameters to get the completed parameter. And they are still just storing the value in parameter store. So your application, the value is still securely stored, securely stored in parameter store and encrypted. And only your application that is defining the merge template would have access to it, nothing else. Gotti, you're looking like you had something. No, he's like, no, I don't have anything. Okay. All right, so I'm gonna show you guys real quick, syncing and replicating. I don't know how to hold this while I demo. I don't. Testing. No, it doesn't work. I'm really like confused right now. I don't know what to do. If I can like put it in my shirt. Oh, there you go. You know, like those mic stands that like what's this? Never mind. The ones that like swing out the booms or whatever. That's what I need. Testing. All right. So for the people online. All right. So the Snag CLI is the CLI utility that we're using. In this case, what I want to do is demonstrate syncing and replicating a config. So I have a configuration defined here. So this is my declarative configuration. It's very simple for a very simple service of a service that I want to deploy into Elastic Container Service. I'm saying I want it to deploy as this kind of worker service. I can go over that a different time. I want to apply these particular plugins, which I can go over some other time. But my service lives under foo. The name of the service is foo in this example. And it requires these 4 parameters: person name, so a person's name, their favorite food, their favorite language is supposed to be a programming language, and a log level. And also my service depends on the run environment. So we need to get the run environment from this kind of shared namespace. So I'm declaring, hey, I need this. My service needs this to work. So if I was a developer developing at Snag, what I would do is I'd run snag CLI config sync. Oops. I would run snag CLI config sync. Oh, is this in the way? Sorry about that. I'd run sync and I'd sync this file. What this would do is it would look at the state in AWS in parameter store and look at my defined config file, and it would say, okay, you're missing these parameters, you need to add them. Or you haven't set up replication, this needs to be created. So this essentially does this. So it's going to look at the desired state in the config file and the actual state in DynamoDB and in parameter store. So when I run sync, it's going to say, hey, app foo person name is missing from parameter store. We need to add it. So I'm going to add, I spelled that right. Spelled that right? Gotti in there. No description, no secret. It's not a secret. The log level, I'm going to set it to info. Favorite language, his favorite language is definitely Clojure, right? Definitely not JavaScript. I think Gotti likes Clojure. And Gotti, what's your favorite food? All right, that's a good answer. That's a really good answer. Sushi is Gotti's favorite food, everybody. Then it's going to check for missing configs that exist in parameter store that don't exist under this namespace. It's going to set up the replication. And in order for me to get the value, now I can go into parameter store and look and see that these values exist. You notice I did not add app foo runenv. I didn't type that in. I just set up, I want that to have the value of what's in shared common environment, and sync setup replication. That's what triggered an event on a Dynamo stream. And if I do snag CLI config get for the dev environment, I can actually grab that value back because it was properly replicated. So there it is right there. It's already there. And now I've got the value from the shared place. So what that demonstrates is when I ran sync, it inserted the configuration in the Dynamo that triggered an event on a Dynamo stream that got consumed by a Lambda, and that put the value from common or the shared namespace into this destination. We can also see, if I do browse is like a tree-like structure. So we can, so if you notice at the top level, we only have these 4 namespaces. Everything exists in here. So if I browse under foo, I can see I have log, level, person, favorite food, name, etc. And I can print out all of these variables. So they all showed up. They're all in parameter store, Gotti, Clojure, and Sushi. Now, if I wanted to, now I can run my app. Now that I've configured my app, I can run it locally. Joseph, I'm sorry, man. He's like ducking below the screen. So what I'm going to do is I'm going to export temporary credentials so that I can actually run my app locally and access these values. And then my application is under source, So it's called app.py. Yeah, get into the virtual environment here. When I did the IAM export, that actually generated temporary credentials through SSO with a token, and it put them in the .aws credentials file. So my application will by default check environment variables, and it'll eventually get down to the AWS credentials file. So now I have temporary keys that my app can use. So now that I've run my app, all this app does is it has 2 threads. This is demo 2, sorry. Now we're on demo 2. So I just ran my application. Let me take a second. Thank you, Joseph. So I just ran my application. My application is this guy right here. What I'm going to demo next is live reloading configurations, which for the most part, I think is a bad idea. But you could hypothetically do this. And if you're going to do it, you probably shouldn't do it by just every 5 minutes getting the latest configs. That just seems unnecessary. So what I have written is an application that has 2 threads. One is an event consumer, and one is the config logger. All it does is loads its configs from parameter store when it starts, and it just prints them out. And that's what it was printing. It's going to print out Gotti and his favorite food is sushi, and his favorite language is Clojure. What I can do then is use the Snags CLI to change one of Gotti's favorite things. That will generate a CloudWatch bus event that ends up on the CloudWatch bus. It gets consumed by Lambda, and then it hops into Kinesis. We're going to pipe it into Kinesis, which is Amazon's version of a event stream. And my consumer is just listening to this stream. It's just listening for anything that may happen, any events that changed. So it's going to get an event that says, Gotti's favorite food is no longer sushi, it's pizza. And my application will then establish a lock, update the variable, and then now we'll print out that Gotti likes pizza instead of sushi. So that's the second demo. So I'm going to do that real quick. Does anybody have any questions about how that works? Gotti, go ahead. Oh, sorry. So I don't believe that I can write, maybe I can, I'm not aware of it. I don't believe I can write a Python app that I run locally that can tap directly into the CloudWatch event stream. Maybe I'm wrong, but I believe you have to, like Lambdas can consume from it, but I don't know if you can just tap directly into that stream. I think you have to have like a Kinesis stream because this is running locally. I see some skeptical faces. They're like, I think you probably can do that. Gotti, you're about to say something. Okay, Gotti has a lot of thoughts about this. So like I said, I personally wouldn't recommend live reloading configs. I don't know if it's necessary to inject Kinesis just for the sake of doing this. This is more just of a demo of how this works. But yeah. Okay. What's that? Oh, come on, man. Okay. Gotti's trolling me for those on YouTube. They are actually, yeah, it's the, never mind. Yeah, oh, thank you, man. All right, so here is the example. So right now, as you can see, Gotti's favorite food is sushi and his favorite language is Clojure. So I'm going to leverage my Snags CLI. Will you hold this, be my boom for a moment? So Snags CLI, would you like me to do that? All right, I'm going to put a variable in the development environment for app foo person favorite language. All right, favorite language. Gotti's favorite language is now Python. Oh no! Okay, so it's now there. Now, one thing, just so you all know, events are usually very fast and you consume them and they show up and everything works very quickly. But for the life of me, I cannot get the CloudWatch event stream to not take 30 to 45 seconds every single time. It's very annoying for presentation purposes. So we have about 45 seconds or so that we have to wait for that event to be generated. Now, as soon as it's generated and it shows up in CloudWatch and my Lambda consumes it, it's basically instant to go through Kinesis and down to my listening consumer. But it takes about 45 seconds for some reason. One thing, interesting fact that we discovered today while trying to figure out why this is really frustrating and annoying is that CloudWatch IAM events, so if somebody, say, creates an access key, those are consumable basically instantly. But for some reason, maybe because they're high priority, Oh, there it is, Python. So it worked. So what it did is it detected a record change for favorite language person, and it just updated that one for us. And so now we can live reload our configs by getting this event through the stream. What was the other thing? I'm trying to think. I had something else I wanted to show. Oh, yes, I remember. The one other thing I want to show, Joseph, boom. Okay, so, all right, so I'm blocking it again. Let me just move it this way. All right, so as you all recall, if I do snagsli config sync, it will tell me everything's good. You're gonna see a bunch of green because all my configs exist. But if I delete one of them, I will get an error. So I'm gonna delete Gadi's new favorite language. All right, it's gone. So now that that's gone, if I do a sync, my sync's gonna tell me, hey, you're missing something, you need to add it. It's gonna ask me to add it, actually, is what it does. I'm not going to add it. Instead, I need to make a change. Oops, VI readme, not get VI readme. Sorry, 1 second. What the heck, Ari? There we go. Let's add a heading up there. Okay, sorry, thank you, Joseph, for the boom. All right, I have triggered a deployment of my application. We use Circle CI, for those of you who don't know, now you know. So the first thing it does is it's going to install our automation repository, and then it's going to run a test in the build, and it's going to build a Docker container. But in the final step for deploy, that is where the validation happens that, hey, this config is missing and it's expected to be there. So we're going to have to patiently wait for this to go. And while that happens, does anybody have any other questions? Yes, sir. So, good question. The question is, do we have a way to trace configuration changes back to a user story? The only way that I can think of where that would be absolutely possible would be if you could see the commit where they added it to that config.json. That commit would be associated probably with some feature branch, and that feature branch would be associated with a particular ticket or something like that. So you might be able to see. We definitely can track who changed it and when, but we wouldn't necessarily know what story it was associated with unless it was part of a commit that was associated with that story. Okay, deploy step. Here we go. Anybody else have any other questions while this is going? Oh, the build broke. Hopefully it's for missing a configuration value. Yes, we are. It just so happens that appfoo person favorite language is missing, and we expect it to be there, so you can't deploy this application because it's going to break. Anybody have any questions? So the question is, why is it a bad idea to dynamically reload configs while running? One thing I mentioned earlier in kind of what our goals were is a mapping between application versions and configs. So I think it's really nice to know exactly what config version is running at what particular time. So if you know that this application was running this version at this time, you should be able to know what config it bootstrapped with. And if you change it at runtime, then you have that problem. Oh yeah, I did have one more thing. And then I have another demo, but thank you all for your patience. I know it's actually 7:58. So let me just run sync again and give Gadi a new favorite language. I'm typing with one hand here. All right, so I added closure, and now, okay, everything's good. So now if I run my app, this is the boom again. I'm blocking it again. Okay. So I'm running my application, and it can run again because the configuration exists. We also, what I'm going to do now is I'm going to put a configuration of log level. The reason why I'm doing this, so now we have to wait 45 seconds. trying to change back to the tab that's running the application. So right now we can see we're logging an info log level. The only thing, well, I don't want to say the only thing, but in this application, certainly the only thing that should typically be changed, or most applications, is the log level. It's really useful to dynamically enable debug or trace for a little while and then turn it back off without having to redeploy your application. It's frustrating to have to wait and trigger deployment just for changing log level. So in 45 seconds, actually whoa, that was a lot faster than 45 seconds. So it's a little bit unpredictable. But now we've got debug stuff that should start coming through, and it just says I'm still running. So I just dynamically updated my log level on a running application, which is useful. Okay, last thing. All right. Back to, hold on. One hand is kind of hard. Okay. Last demo. Okay, parameter store template. So this is inspired by console template. For those of you who are not familiar with console template is this really nice open source utility created by HashiCorp that works with console. What you do is you run a daemon process inside of your container or on your application server, and it will look at the values stored in console. Console is a key value store. So we'll look at what those values are, and if you change one of them, it will just re-render your application configurations, or you're using a templating method. So you would define a configuration file, and you would reference the console values in that file, and if those values change, console template will re-render that file, and then it will run a command to restart the application or reload the config for the application. We use this for our Canary deployment process. So as we deploy our applications, we use Nginx to shift traffic from one version to the next. Nginx can do that, but you have to update its configuration and then reload it to, say, send 1% here and 99% there, and then 2% here and 99% there. Console template is virtually instantaneous. I mean, it is faster than you can check. It's less than a second between the time you update the parameter and it actually updates it. I believe, I'm not sure, this is just me making stuff up, but I think it actually has like an open socket and it pushes the update to the client, but somebody else may know more about that than me. So we created, and by we I mean this guy right here next to me, Joseph, pretty much created a Rust daemon that can act as the console template daemon. And instead of talking directly to console, because we have no console, instead it consumes from parameter store. So we intend to migrate to this instead of console because we're moving off of console. So the idea is you can use this to take up or put down a maintenance page without having to deploy anything. You can use this to shift traffic to a new service or reload configs in general for any one of your services. And all you do is define a template just like in console template. And you will have to create a little bit of infra. You will have to create a Kinesis stream because this thing will consume from a Kinesis stream listening to events or changes for configurations it's interested in. So, last demo, Joseph, boom, thank you, sir. Is it called a mic boom? Is that what it's called? Joseph boom. All right, so I don't really have to do much here. All I have to do is load. Dang it. Okay, so demo SSM config. This is a website Joseph put up. This is just an Nginx. It's just loading this website called, or this library called Cornify. It just displays a bunch of random unicorns. So what we can do is we can put up a maintenance page all of a sudden. So let me, 1 second, I want to tail the logs. So one thing we have here, one thing that's really nice and that we created with our Snag CLI is that we can tail the live logs of any particular service. So there's a log tail command, and I can specify a service. What's the name of the service? Demo SSM config. This uses a WebSocket, and it taps into a Kinesis stream where all of our logs are kind of piping through, and then I just get the logs that are relevant to the service. So what happens is if I reload this page, I should be getting logs. Here we go. I've got 200s coming in from a health check and stuff like that. So what I will do is use a different tab here with the Snag CLI. And I'm going to update the value that console template, or sorry, parameter store template is watching. which is demo SSM config. So what I'm going to do is I'm going to do two things. I'm going to disable 200 logs, and I'm going to enable the maintenance page. Okay, so that should do it. Let me hop back over. All right, so these are the logs. So we should stop seeing 200s once the message comes in. And I believe Joseph added a little bit of logging today. So we'll pop up and say, hey, this thing changed, and I'm going to re-render the config, and that should turn off 200 logging. And when we see that message come through, I will then reload the page in the browser, and we should go to like a maintenance page. So we use this internally with console template to quickly put up and take down maintenance pages without having to do deployments, anything like that. So if we have an incident, we just will throw up a maintenance page rather than everybody waiting for a million hours and unable to load their application. There it is. Hey, look, so maintenance enabled has a new value of 1, and it executed Nginx reload. It also got a message for log 200s has a new value of 0, so it disabled logging. So we should no longer see 200s logging in here. And if I reload our page, we have a maintenance page. So this is open source, so if anybody's interested in using this, you can do this fairly easily. It's written in Rust, so it's very lightweight. And we intend, we would love other contributors to improve it. It's really was just a hack. We have a hack day at Snagajob, so once a month, everybody just gets to work on whatever they want. So on one hack day, Joseph and I kind of put this together. That is the end of the presentation, but I know there may be at least a few questions. So if anybody has any other questions, now is the time. Yes, sir. No, it's not. Yeah, it was all Christmas, all December of last year and some of November. Yeah, it was a lot of work. Yeah, so that's kind of part of when I talked about developers won't use something unless you make them want to use it. That was the idea. Developers are the consumers of our automation. They're consumers of the tools we use. If we don't make them really useful, they just won't use them. So the idea is that people make the thing really cool and people will want to use it. It is not open source. It's just too deeply ingrained with our existing architecture in AWS. So it can't easily be extracted. Yeah. It has some neat tricks. Yes, sir. Yes, they are. They're all those shared so the question was around shared libraries that the apps use to bootstrap and pull configs from Parameter Store. Yeah, those are all. We have one kind of giant. I don't want to say giant, but one kind of general shared library for .NET Core called our Core library. It's maintained by an unbelievably good engineer, and he basically creates all kinds of utilities that everybody can then use, and it's versioned and they just upgrade it and they get free cool stuff. So that's how that works. Yeah, so then I work with him a lot. So when I did this Snags CLI thing, I was like, hey, I'm gonna do this. And he's like, wouldn't it be cool if just running this command would auto-generate the CI config.json so people don't have to manually enter stuff in there? And I was like, yeah, that sounds amazing. I never thought of that before, but that's an amazing idea. And then he had it done within a few hours. So that's kind of how we do it. Internally, we have a little bit of Java, a tiny bit of Scala, which will be gone soon. We have all of the DevOps stuff. That Snags CLI is written in Python. So Python is primarily the DevOps language. Although Joseph likes to dabble in Rust, and but we don't do a whole lot of stuff in Rust, just that one kind of open source project. Other than that, we also have, I think I said .NET Core. I don't know if I said that, but we use a lot of .NET Core, and there's some legacy stuff in older .NET that doesn't run on Linux. And then, of course, JavaScript. Obviously, there's lots of JavaScript everywhere, and like Node.js, some of that stuff. I think that's pretty much it. So one of the challenges is, of course, whenever you write stuff like this, and you have a guy with a shared library that is using .NET Core, and you get all these nice features, there's not always a guy to do it in Python. And there's not always a guy to do it in Node.js and all this other kind of stuff. So some people may get a better developer experience. So the goal really should be, in my mind, like we would like to standardize on fewer languages and just offer more features around those languages. The question is related to the last meetup, which was about customer data or something like that, but unintentionally our users' data unintentionally being logged and ending up in our logs. Do we have any protections around that? The only protections we have are really just all the stuff that I went over last time, which is all the live filtering and the regular expression library around detecting, you know, sensitive data and then obscuring it and removing it before it actually gets into Elasticsearch or you know, logs. So no. So hypothetically, someone could pull a config and then log it. We wouldn't have, I can't really, at the moment, I can't really think of a way to prevent that other than trying to detect it in the logs through regular expressions with our existing system. At the end of the day, developers have to be good stewards of the secrets and the configs, and they shouldn't log them. Obviously, people make mistakes, and that's why we have a secondary system that tries to detect them and scrape them and scrub them out before they ever get logged and show up in you know, our log archives, etc. Jason, go ahead, sir.
Could you basically have done this with any other parameter store system? It doesn't look like you're using a lot of Amazon parameter store specific features, having built your own logging functionality, versioning. Would it be easy to migrate to anything else, or for someone else who doesn't use Amazon to use some random parameter store?
So the question is, sorry for the YouTube video. The question is, would it be easy to do this kind of system outside of Amazon or leveraging some other existing kind of key value store or config storage system? The answer would be no. We pretty much very heavily use all kinds of very unique Amazon features that most other, or pretty much all other key value stores that I'm aware of don't support. Some of the events you might be able to leverage it, because I know like with Mongo, if you insert a record to Mongo, kind of how DynamoDB has streams, Mongo has some kind of similar concept. But it would be totally custom. This is largely custom as well. So like to me, one of the big advantages of AWS is it's not too terribly opinionated. They create a bunch of services that are all super useful, and they make it really easy to tie them together. So that's kind of what we did here, is we just tied a bunch of really useful services together to achieve an end. Anybody else? The question is, before we left console, do we look at Vault? In fact, Vault was our first choice. We installed Vault and configured Vault in our development environment. And a guy that did that ended up leaving. And Parameter Store came out, I don't know if it was already out or it was very new, I believe, at that time. And we kind of realized that Vault's very complicated and it involves running your own, running your own infrastructure to run Vault. Also, Vaults, I recall, we set up like the failover, and it's like an active passive failover. It's not have the same kind of high availability kind of setup that we typically use. It just seemed complicated, and if Vault breaks, everything breaks, and it was like a single point of failure, and it was just made me nervous and made other people nervous. And so we kind of realized we didn't need some of the other features that Vault has, we wouldn't be using them. And so we just thought Parameter Store is simpler, and it's got a really nice IAM integration. It's a lot easier for us to just take our existing knowledge around IAM and write policies to limit access and do all the stuff we did than it is to learn Vault's policy syntax and how to manage policies and all that stuff. And, you know, Vault is no doubt like amazing. It's just a lot to learn. And, you know, our DevOps team is like 6 people. So, you know, Vault's one of those things and I may be totally wrong about this, but it's one of those things where like you need an expert that they have to be the Vault guy, and they spend a lot of time managing Vault. And now that this works, like nobody manages it. It just does what it does, you know? So we just put in some time developing this system, you know, took about like a couple months or so, and then rolled it out, and now nobody touches it. Yes, Eric. Yeah, the question is how are we using KMS with this? So Parameter Store, whenever you put or pull a value from Parameter Store, you're using an SDK that Amazon wrote. So in Python's case, it's called Boto3. Whenever you call Boto3 put parameter, you can specify a particular KMS key and the ID of the key. And if that you have access, if the user that's putting the parameter has access to the key, the SDK will basically encrypt the value for you and put the encrypted value in parameter store, and parameter store will say this has been encrypted with this key. So we're just leveraging the AWS SDK, and parameter store just kind of natively already supports this with the AWS SDK. So that's just kind of the integration. It's really quite simple. You just specify, I want to put this in encrypted with this key. And you can also specify like particular, what's called, it's kind of like a salt. What's it called? It's like an encryption context. The context, yeah. You can specify an encryption context. So anybody that wants to decrypt that value, even if they have a key, they have to have the context. That way, one person can't just decrypt everything that's been encrypted with that key. They would have to have the context for each individual item that they decrypt. Question is about AWS Secrets Manager. Yeah, so we do not use AWS Secrets Manager. Far as I can tell, there's no real advantage outside of it has an integration with AWS RDS. So you can like auto rotate passwords with it, stuff like that. We do use RDS, but our biggest, most sensitive databases are Mongo and SQL Server, and we don't run those in RDS. So we just don't use Secrets Manager at all. Gotti. Yeah, so the question is related to not everything is just a simple string that you can store in parameter store. You might want to store a certificate or some file or something. Now that you can store, well, one thing is for certificates and like SSH keys or something like that, now that you can store larger things in parameter store than before, now you can actually store a lot more than you used to be able to in terms of certificates. But we might use, I think we do use that in a couple places, but for files and things like that, I think we primarily just use like very sensitive lockdown kind of S3 buckets for those files. We don't store them in parameter store or anything like that. Another thing before everybody kind of heads out, Snag is hiring. So sorry, but I meant to put this at the beginning before a lot of people got tired and left. But we are actually hiring a site reliability engineer, and we actually may have a DevOps opening in the future. So if you or know anybody who might be interested in working at a company that's doing some pretty cool stuff, at least I think it's pretty cool, feel free to reach out to me on LinkedIn or here or wherever. I know a lot of you work for really great companies and everything, but if you know anybody, please let me know or let them know about us. Great question. The question is, what is the difference between SRE and DevOps for me, or for us? Sorry, for Snag, obviously. Sorry, not for me. So for Snagajob, we are expanding our SRE team. There's currently 3 members on it. DevOps manages all of our infrastructure, essentially, and manages pretty much all of our automation. The SREs handle, of course, all of, like, not all incident response. Every person in Snagajob that's an engineer is on call, but they are our expert troubleshooters. They also, and Ryan, you can probably do a better job than this, so I may hand it out over to you, but they also, okay. They also act as an intermediary between some like product or clients, things like that. And they also do write a lot of automation to improve our kind of monitoring and incident response. And they do all of the no blame, what are they called? The no blame, blameless postmortems. Yes, they handle all of those, of course. And so they're extremely integral to the company. And we desperately need one in Charleston. So we're looking for kind of a senior level SRE and ideally someone with some development experience. We want to really get us, I want an SRE that can do some coding, you know, obviously, because we want to write automation for automated remediation and automated incident response and all that kind of stuff. Yep. Anybody else have any other questions? Thank you. Thank you, Joseph, for being my boom.